So we didn't get a chance to do this problem in class yesterday, so I wanted to go through it right now just to help you think about these types of synthesis problems. And again, just to see how I think about these problems. Again, hopefully that'll help you as you continue to improve your abilities to do these synthesis problems. So this is problem number 3 on our group problem sheet. Right? It's make this compound from 2 carbons or fewer. And it's pretty complicated because we have a lot of carbons. And we can only start with 2 carbons or fewer. So remember what our strategy is when we're doing these problems. First thing, number everything out so we can make sure it's clear where all the carbons are so that we don't add one or lose one. All right, so we have 7 carbons. And we have to start from 2 carbons or fewer. So we're going to have to make several carbon-carbon bonds. This is not going to be a one-step synthesis. Right? So this is really going to help us to think about our retrosynthetic analysis because it's very unclear how we can start this problem with all of these carbons and only 2 carbon fragments to work with. So as we begin this problem, I want to encourage you to think backwards. All right? And I want you to look at this and say, all right, I know this is a tertiary alcohol. How can I make tertiary alcohols? All right? So this is our tertiary alcohol. And hopefully you're thinking, all right, I can make tertiary alcohols. We can take a ketone and add a Grignard or alkylithium, and that's going to give us a tertiary alcohol. Right? And there are several ways you can imagine splitting up this tertiary alcohol. And again, when we go backwards, we're going to think, all right, we're going to form the carbonyl. It's going to come from a carbonyl. And we can break the 4-3 bond, the 4-5 bond, or the 4-7 bond. But when you know you have 2 carbons or fewer to work with, it probably makes sense to split off the 2 carbon piece. Right? If we split off over here, we have a 3 carbon piece. Let's split off the 2 carbon piece. Right? So we're going to end up breaking that bond, and those electrons are going to go on to carbon 5. So if we think about what that looks like in terms of the compounds we're going to react, we're going to have a ketone plus some sort of Grignard reagent. Let me actually write that a little bit better. All right, and now let's number to make sure we didn't mess anything up. So 1, 2, 3, 4, 5. Again, you have to be really careful. 1, 2, 3, 4, 7, and then this is going to be 5 and 6. Okay, so again, just looking back, we're breaking the 5-4 bond. Here we have carbon 5 as a nucleophile, carbon 4 as the electrophile, and this is a 2 carbon piece. So that's something that we can start with. We're done with that. Now we have a 5 carbon piece that we need to make, right? And this is a ketone. So we need to think, all right, how can we make a ketone, right? And we have a couple of ways to make a ketone. And so, we could possibly explore several ways to make a ketone, right? We can think about, well, I know a ketone can come from a secondary alcohol by oxidation. We talked about that reaction yesterday. So we definitely could think about something like that, right? And you could think about doing this. This is either PCC or chromic acid, okay? 1, 2, 3, 4, and 7. We can also make a ketone by doing a reaction of a carboxylic acid with 2 equivalents of an alkylithium. Right? So that might be a way to simplify this by breaking a carbon-carbon bond. Right? We would end up breaking off that piece so that we would have carboxylic acid plus 2 equivalents of methyl lithium. And again, number it out. That's 7. 1, 2, 3, 4. All right, and it doesn't really matter to me which way you go with this. I think you can come up with a pretty good answer either way. So whatever one you want to explore is fine with me. Right? But again, with many of these synthesis problems, we're going to have multiple correct answers. All right, let's focus on this secondary alcohol. ask ourselves, how do we make a secondary alcohol? Well, hopefully we remember that it's an aldehyde plus a Grignard reagent or alkyl lithium, right? And you can imagine splitting this one of several ways, right? Because it'll look just like what we did from the tertiary alcohol, right? We're going to form that carbonyl, and then you can break either the 3,4 bond or the 4,7 bond, right? I encourage you to take a look at both of them. I'm only going to focus on one. I'm going to focus on if we break off the 4,7 piece. So that would give us an aldehyde plus methyl Grignard. And again, we can number this out. And then that's carbon 7. Okay? So that looks like a reasonable reaction to me. Right? Again, you could have split it on the 3,4 bond. I encourage you to do that, and I encourage you to check that out and figure out why that's not going to be a successful route for us. It's going to be impossible for us right now to get back to 2 carbons or fewer if we split the 3,4 bond and have a 3-carbon Grignard plus a 2-carbon aldehyde. Right? So I encourage you to take a look at that on your own. Now, we've simplified this. Let's go back to the other synthesis. Right? This is a carboxylic acid. We have a couple of ways that we can make a carboxylic acid now. We can make it by a Grignard reaction, or we can make it by an oxidation reaction. If we think about making it by an oxidation reaction, we can say that the carboxylic acid came from primary alcohol. 1, 2, 3, and 4. And the interesting thing is this is where these two syntheses would converge, because you can get from a primary alcohol to the aldehyde by PCC. Right? So we have 2 different routes connecting back at that primary alcohol, and that's one of the key things in this synthesis. Right? If you can get back to that primary alcohol, then you're in good shape and you're going to be able to solve this problem. Right? Now, thinking about how to make a primary alcohol, right? I think the obvious one would be, well, primary alcohol comes from disconnection of the 3,4 bond, and it's formaldehyde plus a Grignard reagent, right? So we could say this is going to come from a 3-carbon Grignard reagent plus formaldehyde. Right? That reaction is definitely going to work, and that's going to give us the primary alcohol we want. Right? And then we have to figure out how to make this 3-carbon piece. Well, that's going to come from that bromide. But that's a dead end for us. Right? We don't know how to make this 3-carbon bromide. Right? We'll learn, but right now we don't know. All right? So this route turns out to be a dead end. Right? Really good idea, and if you end up doing a synthesis problem and you hit a dead end like that and you can't figure anything out, this is a very good answer, right? But there is an answer that's better. And the answer that's better comes from remembering that we can make primary alcohols from epoxides, right? So this is the disconnection we want to make, right? And we need to think about an epoxide reaction. All right, I'm going to ignore the phone. All right, so if we think about an epoxide reaction, we're going to react a 2-carbon Grignard plus ethylene oxide. All right, and let's number these things out. And we have our 2-carbon pieces. All right, so that's a beautiful reaction that enables us to split this thing right in half and get back to the 2-carbon pieces we need. All right, so we have 2-carbon Grignard, 2-carbon epoxide, going either way. We have our 1-carbon alkyl lithium or 1-carbon Grignard, and our 2-carbon Grignard as well. Right, so really beautiful disconnections to make this. Right, and then the final thing that you would do if you were doing this out is that you would want to do the forward direction so it was clear exactly how to do the synthesis. Right, so let's just do that as our final piece to answering this. Right, so the forward direction synthesis, right, we would start with ethylene oxide. We'd react that first with ethyl Grignard, acid quench. That would give us the primary alcohol, right? And again, you could go either direction that you want here. Let's go the carboxylic acid route. So chromic acid. That gives us the carboxylic acid that we want. React that with 2 equivalents of methyl lithium, acid quench. That gives us our 5-carbon ketone, and then we just have one step to get to our target. We need to add ethyl Grignard again and an acid quench. All right, so we did a really nice job here with a 1, 2, 3, 4-step synthesis of our target, beginning with things containing 2 carbons or fewer. Right, so I hope it helps going through all of this and thinking about this strategy as you look to do these sorts of problems in the future.